Okay, this is Math 2, Unit 8, Lesson 1, Properties of Exponents. This is review. At least the first part of these notes are review from previous math classes, as far back even as middle school. Some of the stuff you learned back in middle school, so we're trying to jog your memory, make sure it all comes back. Number 1, some of this stuff we've been talking about since our last lesson that we did on Tuesday. Okay, what do when you have x squared times x cubed? We talked about this on Tuesday. What do you do with the exponents? You add them. And the bases stay the same. It doesn't become 2x. It stays x. And you add the exponent, x to the 5th. So put a little note there. You're going to add. Okay, what if we have something like this? Number 2, parentheses, x squared, close parentheses, third power. Do you see the difference between these two? This one I have two different x's multiplying together. Here I have one x raised to a power raised to another power. Who remembers what you do there? Yes, you multiply. Did anybody else remember that? Do you guys understand or remember why? Why you add and why you multiply? Okay, I'm going to do a quick review. This quick review that you do not have to show this work. I just want to quickly explain why, just in case you've forgotten or you weren't told. Okay, x squared means x times x. You learned that back in elementary school. Do you agree? X to the 3rd means x times x times x. You learned that back in elementary school. You also learned in elementary school that you would add all the exponents up. Maybe that was middle school. 1, 2, 3, 4, 5. So what does it end up being? X to the 5th. So if I were to expand that, and then do it all together, would I end up with x to the 5th? Yes? All right. Same thing here. X squared to the 3rd means I have this base 3 times. X squared times x squared times x squared. Noah, Wood, why did I write out x squared 3 times?
Because you have to multiply, or you add them all together.
Don't tell me about adding yet. Take a step back. Why do I have 3 of them? Why not 4x squareds or only 2x squareds? How do I know to write?
It's multiplied by 3. X2 is multiplied by 3.
Because it's raised to the 3rd power?
Yeah.
That power tells me the base 3 times. Guys, one of you guys and girls take hoods off and earphones and phones put away. All right, now going back to this that we learned over here, we add the exponents. What's 2 plus 2 plus 2? X to the 6th. Now again, this was just a quick review. Do you have to show the breaking down every single time? No, you do not. All right, more review. Number 3, x to the 8th over x squared. Write down what you think the answer is. X squared, or x to the 8th divided by x squared. X to the 8th over x squared. Anybody write x to the 4th? Okay. How did you get x to the 4th? Anyone? Divided 8 by 2 makes sense because it's a fraction. Fraction means to divide. Did anybody get something different than x to the 4th? What did you get?
X to the 6th.
X to the 6th is the correct answer. Now, I wanted you to try this one on your own just to see where everyone's at. It's okay if you put this. Just make a note to yourself that that's not the right answer. It's x to the 6th. Now, if you didn't get x to the 6th and you're looking at it now, does anybody remember now that you've seen the answer what you do? What is it? I can't tell where the answer is coming from. Thank you. Subtract. Now, why do you think kids divide? A fraction, you've been taught since the beginning of time that a fraction means to divide. It makes sense that 8 over 2 is 6. But is this really 8 over 2? No, it's x to the 8th over x to the 2nd. So, if you were to expand it, like we did up here, how many x's would I have at the top of my fraction? 8? 1, 2, 3, 4, 5, 6, 7, 8. How many would I have at the bottom of my fraction? 2. And when you reduce a whole set of x's at a time. So all of my x's don't reduce, but how many sets will reduce? Do you agree the two sets reduce, leaving me with how many x's? 6. All right, so when dividing, make sure that you remember to subtract the exponents. You add the exponents here, you multiply the exponents there, and subtract there. Got the difference? All right, we're going to continue reviewing number 4, x to the 0. Does anybody remember what that is? X to the 0 power. As long as your base is not 0, it is 1. Good job. Do you guys remember that? Did you learn that last year or in middle school? Do you remember? This year? We did talk about it. You did learn it somewhere before. I don't know if it was Math 1 or back in middle school, but x to the 0 is 1. All day, every day. As long as the base is not 0, your answer will be 1. 1,000,000 to the 0 power is 1. Questions on that one? No? No one needs to hear that one explained. You're going to accept it as fact, which is okay with me. No one wants it explained? All right. Number 5, another review from last year. X to the negative 4th power. We did, no, I didn't talk about this one yesterday, or Tuesday. Do you guys remember this? Does anyone remember this from last year's math class? What your teachers, your Math 1 teachers taught you? No one? Not one person? Something with a fraction? Something with a 1? No? 1 over x to the 4th. All right. You will not leave your answers with negative exponents. You will always move it to the bottom. 1 over x to the 4th. So this moves to the denominator, leaving behind a 1. It doesn't leave behind a 0. It leaves behind a 1 because there is a coefficient of 1 there that we don't see. And once you move it to the denominator, the negative exponent becomes positive. All right? So, number 6, I just want to quickly review or go over with you a commonplace kids mess up. Now, I'm not going to lie and say this test is easy. There is a lot to it. There is a lot on this test, a lot of old stuff that is assumed you knew, you've learned, you've got it, you're good. So you want to make sure stuff like this that you learned last year, you freshen up on. Okay, why do you think kids mess this one up? Because there's 2 negatives and there's 2 pieces here. There's a coefficient, there's an x. What moves, what stays? Okay, here is the deal. That negative exponent, is it attached to the 3 and the x or just the x? Just the x. So let's move that first. I'm going to cover this guy. When it moves to the denominator, x to the positive or negative 2? Do you see how that worked? Okay. Now, kids will say, well, the 3 is negative, so it must move to the bottom. It does not. Anybody think they know why? I'm going to repeat what I said. Kids will often say, well, if the 3 is negative, it should move to the bottom. But it does not. It stays at the top. Does anybody think they know why? Yes.
Oh no, just stretching.
Just stretching. Anyone else think they know why? There was something out there. Something about the position of the negative. Yes.
It's only a coefficient, not part of the exponent.
Beautiful. Did everybody hear her? Can you repeat it one more time, a little louder?
It's only a coefficient and not part of the exponent.
Okay. This negative is a negative coefficient, where this negative is a negative exponent. Is there a difference? Yes. Negative exponents move to the denominator. Negative coefficients stay put. You do need to know that. All right. Any questions on the review before we move on? All right. Part 2, examples. Now these examples are still review. They're still review. We're gonna make them just a little smidge bit harder than the 1 through 6 at the top. Number 1, negative 5x to the 3rd times negative 3x to the 6th. When you see these problems, the first thing you want to look to see if there's any powers on the outside. On either one, are there any powers on the outside? No. So we can just drop the parentheses and multiply the coefficients, just like you learned back in elementary school. You multiply. What's negative 5 times negative 3? Positive 15. Now, this here, if you were to rearrange it, would be, I'm just going to put it up here really quick, x cubed times x to the 6th. Do you agree if you were to rearrange all this, it would be x cubed times x to the 6th? And what do we do with the exponents when we're multiplying like bases? Add to them. And 6 plus 3 or 3 plus 6 is 9, and x stays x. Negative 5 times negative 3 is positive 15. X to the 3rd times x to the 6th, you multiply the x, or add the exponent, sorry, and you get x to the 9th. That there is your final answer. All right, I'm going to have you try the next one. 7 to the 6th times 7 to the 5th. Go ahead and do that one on your own. All right. Anybody get 49 to the 11th? Don't erase your answer if you have something different. Anybody get it? Why would I get it wrong? Okay. I add the 7s or the 6 and the 5? Good question. The 6 and the 5. And what's 6 plus 5? Okay, so it does equal 11. So then why is this wrong?
Because you don't multiply the 7.
Can you repeat that louder so the people across the classroom can hear you?
You don't multiply the 7.
You don't multiply the 7s. Do you see that? And I did say it earlier, when multiplying like bases, you add the exponents, but the bases stay the same. When multiplying like bases, you add the exponents, but the base stays the same. So it should be 7 to the 11th power. Did anybody write it that way to begin with? Good. 7 to the 11th power. I just went over this because this is a common mistake that kids make. They say, oh, it makes sense. 7 times 7 is 49, just like 8 divided by 2 is 4. But that's not what's going on here. Bases stay the same. Okay. Number 3. 5 to the 6th times 5 to the negative 2nd times 5 to the negative 1. Now, you have a lot going on here because you have exponents and you have positive exponents and negative exponents. And we talked about negative exponents moving. I will tell you this. Before you do any moving, work with the exponents first. Do all of them have the same base? So what are we going to do? Add or multiply the exponents? Add. So do that first, because you may not have to worry about the negative in the end. If you do, adjust it or address it at that time. So add 6 plus negative 2 plus negative 1 comes out to be what? 3. So is my final answer 3 or 5 to the 3rd? 5 to the 3rd. What's 5 times 5 times 5? 125. I want to say, I'm going to erase that. I know there's some on the worksheet where it tells you to leave your answer in this form. If it does tell you, leave it. If it doesn't tell you that, then you expand it out or multiply it out. All right, number 4. Negative 8n times 11n to the 9th power. I'm going to give you guys just a few seconds to try that one on your own. Sartaj, can you tell me what you did? Negative 8 plus negative 11? Yeah, and then what did you do after that? I couldn't hear you. Speak louder.
-900.
What did you do with the exponents after that? That's what I'm asking you.
I just
And if you're not sure, that's okay. I'm not sure. Okay. What I would suggest on these, and I should have done it on number 1 and I did not, so I'm going to address it here if you are struggling with these. It helps mentally get a picture if you rewrite it. Remember that multiplication is, put phones away, put your earbuds away. Multiplication is commutative, meaning you can move things around. So this is equivalent to this. Move the coefficients together, move the variables together. That is the same thing. So I'm going to cover this. Sartaj, can you tell me what you would do if you saw this on a homework assignment? -8 times 11. That's it. That's all you saw. What would you do?
-8 times 11.
You're correct.
Yeah,
Yep. Okay, so what is -8 times 11? -88. Okay, so what you want to do, because it's confusing, when are you multiplying, when are you adding, what are you doing, rearrange it, and when you see that, that should ring a bell of like, oh yeah, I just multiplied, -88. And then when you see that, you should know to do what with the exponents? Add them, but there's nothing here. What's there if there is nothing there? A 1. So you put that 1 in its place, and then add. What's 1 plus 9? So you get -88 into the 10th. Do you guys vaguely somewhat remember this from middle school? Yes? Did you guys do it last year as well? Yeah?
I don't think I've ever done it, to be honest.
No? Not at all? Not even from middle school? Does it make sense at least?
Yes.
Okay. Number 5. X squared, and I'm going to fix that. Please don't write it down yet. That's going to be x to the -2nd. X to the -2nd power raised to the 8th power. So, you're either adding or multiplying exponents, not coefficients, exponents. What do we do with the exponents? Multiply or add here. Look back if you're not sure. Multiply. When it's a power to a power, you multiply. And it's basic multiplying. Just straight out, what's -2 times 8? -16. So x to the -16. Is it okay to leave my answer with the negative exponent? No. No, it is not. Abraham, can you tell me how to rewrite it? One over x to the positive or -16th? Positive. 1 over x to the positive 16th power. Thank you. Okay, questions on 5. Alrighty, number 6. Parentheses, 5xy squared raised to the 3rd power. All right, this is one term. I'm going to cover all this. It's one term because there's no plus or minus. Do you see that? 5xy squared is one term because there's no plus or minus. As long as there's no plus or minus in the parentheses, you will distribute that exponent to the 5, the x, and the y squared. You will distribute that exponent to the 5, the x, and the y squared. If there was a plus or minus sign in there, you would not be allowed to do that. I'm going to repeat that because what I'm telling you is something we're going to use again and again throughout the year and units to come. Okay, when is it okay to distribute the exponent? When there's no what inside? Plus or minus. If there were a plus or minus inside, would it be okay to distribute that exponent? No, it would not be. Okay, so I'm running into another problem. We know, I'm going to cover this right here, we know to do what when we have a power to a power? Multiply or add? Multiply. My problem is I have no powers here, so I need to put something in. What do I put in that's not there? It's there, but I don't see it. What powers? 1 and 1. If it has no power, put powers of 1 in before you distribute. If it has no powers, put powers of 1 in before you distribute. Okay, 5 is going to stay 5, and 1 to the 1 times 3 is what we're going to do. What's 1 times 3? 3. X to the, again, 1 times 3. What's 1 times 3? 3. And then y to the 1 times 3 or 2 times 3? 2 times 3, which is 6. Okay, so when you have these chunky parentheses to a power, put your 1's in for your exponents that don't have it already, and then distribute and multiply your powers, your exponents. Okay, this one you will have to work out. We talked about it earlier. What's 5 to the third? 125, and then x cubed y to the 6th is your final beautiful answer. Questions on that one? No questions? Okay, number 7. Parentheses, negative 2ab, close parentheses, third power, parentheses, negative 4a squared, close parentheses, second power. All right. Don't work it out yet. Can you guys take a look at, leave your number 7 out, and I'm going to flip my paper over to number 1. The number 7 you have on your paper looks a lot like number 1. There's 2 parentheses, there's 1 term in each, there's even the negative coefficients. Can anybody tell me how it's different? There's something that number 7 has on both parentheses that number 1 does not. What is it? Those exponents there. Do you agree? These two have powers where these two did not. Do you see that? And when I did this one earlier, I said first check if there's powers. If there's not, go straight to multiplying your coefficients. Since these have powers, can I go straight to multiplying negative 2 times negative 4? I cannot. What do you think I'm going to have to do individually first? Distribute the exponents. Now, before I distribute exponents, let's first check inside. Is there any plus or minus? I don't mean negative 2 or negative 4. Any plus or subtraction signs? No. So is it okay to distribute? Yes. Second thing is, make sure you put 1's in. Where do I need to put my 1's? Does the negative 2 need an exponent? I put a 1. Does the a need an exponent? What do I put? A 1. Does the b need an exponent? Put a 1. All right, next set. Does the negative 4 need an exponent? What do I put? A 1. Does the a squared need an exponent? No, it already has it. It's 2. All right, now we're going to distribute. Now, I will tell you this. Like here, I just wrote it 5 to the third. Here, when my bases or my coefficients are negative, I do put them in parentheses. Negative 2 to what power? What's 1 times 3? 3. A to what power? What's 1 times 3? 3. And b to what power? Is that also a 3? All right, I'll clean that up in just a little bit. I'm going to move on to the next one. Again, the 4 is negative, so I'm going to put it in parentheses only because it's negative, and distribute, and 1 times 2 is 2, and then I distribute to that one. A to what power? A to the 4th. Now, before I multiply these two numbers together, I do have to clean it up. Negative 2 to the 3rd and negative 4 to the 2nd are numbers I can actually calculate. So do that now, either in your head, by hand, or with your calculators. What's negative 2 times negative 2 times negative 2? You should be able to do that in your head. What does it come out to be? Negative 8. A cubed stays, b cubed stays, and then negative 4 times negative 4 is positive or negative 16. Positive 16, a to the 4th. Now, this next step you do not have to do. I'm only showing you this if you are still kind of struggling on when to multiply, when to add. Because there's no more powers on the outside, I can regroup. Negative 8 times 16 times a to the third times a to the fourth times b to the third. I just regrouped it so like bases are by each other. Negative 8 times 16, a to the third times a to the fourth, and then b cubed is by itself. What do I do with the negative 8 and the 16? Multiply or add? Multiply, because it's just like you would do back in elementary school. And negative 8 times 16, calculate that as negative. Anybody have it? Come on, guys. You all have calculators on your desk.
128.
Thank you. And I will call on Diego. Diego, on the negative 8 and 16 we multiplied. What do I do with the 3 and the 4? I add them because the bases are the same. Can I add it with this 3 as well?
No.
No, because that base is not the same. So it's a to what power, Diego?
7 power.
Good. Now does b have a like base to add the exponents with? No, so it just stays what? B to the third. I will tell you right now, you will definitely need to know how to do every single one of these steps on your own by test day, even by quiz day. Yes? Good question. Can you repeat your question one more time a little bit louder for everyone to hear? Should the 16 be negative? Right here. You see where it has 16 a to the fourth? Any thoughts? Anyone agree? Anyone know why it's not?
Because you're timesing a negative by a negative, so it makes it a positive.
Okay, did you hear that? Can you tell me what your thoughts are and why it should be negative? Is it because this one stayed negative?
Yeah.
Okay. Okay, so because this, okay, let me ask that question. Let me word it a little differently. Why is this one negative? They were both negative. Why did the 8 stay negative and the 16 become positive? Yes.
Because when you did negative 2 times negative 2, you had to multiply it by another negative 2, which made it negative again.
Okay, did everybody hear him? He said when you multiplied the negative 2 by the negative 2, trying to find scratch paper, sorry. He said when you multiplied right here, the negative 2 times the negative 2 times the negative 2, this is positive 4 times another negative 2 makes it negative again. That's what you said, right? And then what happened here? Can you keep explaining?
Oh, negative 4 times negative 4, since it's a negative, so they're both negative, they change into a positive 16.
And there's no other negative to make it negative. Does that make sense? That was a really good question. I'm glad you asked. All right, so make sure you're keeping track. Just because these two bases are negative, once you raise them to a power, sometimes they stay negative, sometimes they become positive. Anyone want to take a guess about what the powers have to be for them to be negative or positive? That's 3, that's 2. When is it always going to be negative? When is it always going to be positive? No one has a guess? Yes. Even and odd. If it's odd, you're going to have an odd amount of negatives, which would stay negative. If it's even, you're going to have an even amount of negatives, which would become positive. Good observation. All right. Number 8. Negative 3, x to the third, y squared to the third. I know these notes are really long. That's the whole reason why we're only doing one lesson today, because this is a long lesson to get through. Times 2x y to the 0, close parentheses, squared. All right. Is this similar to number 7? Yes? I'm multiplying two terms together. Look on the outside of the parentheses. Do the outside of the parentheses have exponents? Yes. So before multiplying negative 3 times 2, what do I have to do with those exponents? Starts with the D. Distribute. And before I put these little arrows in, I should have first checked. In order to distribute, there can be no plus or minus signs in the parentheses. Are there any plus or minus signs in the parentheses? And I don't mean negative signs. No, there's no addition or subtraction, so we're good to distribute. Before I distribute, what do I have to put in some of the exponents? A 1. I'm going to have Grace, can you tell me where to put the 1s?
By the negative 3.
Good job. All right, and then we distribute the exponent. And when we do, what do we do with the powers? Power to a power, what do we do? Add or multiply? Multiply. Okay, if the base is negative, I put it in parentheses. -3, 1 times 3 is what? Is what? 3. Let's go back to what Erica asked earlier. Is that going to end up being a positive or a negative? Negative, because there's to the third power. Okay, x to the, I'm going to call on Andrew. X to what power?
9,
And then y to what power?
6,
Thank you. All right, next one, because the 2 is not negative, I don't put it in parentheses. It's okay if you do. I don't. All right, I'm going to call on Curtis. Tell me what it is. 2 to what power?
2,
And then y to what power?
2,
And then y to what power?
X.
yeah.
Oh, sorry. He said x and I wrote it down. I love it when you guys are paying attention. Thank you. And then you fixed it here. You said y to what power?
2,
I thought you fixed it. What's 0 times 2? 0. All right, so be careful. 1 times 2 is 2. 1 times 2 is 2. 0 times 2 is 0. So 2 squared, x squared, y 0. Are we good? Yes.
does the y become a 1?
Say it again.
The y.
Good question. Okay, he said, wait, why do we do this? Doesn't y to the 0 become 1? He is correct. Now, let's say you didn't catch it. Could I catch it here and just say that is a 1 in disguise? Yes. If you put the 1 here, you could. 1 squared is still going to be 1. All right, good observation. Yes, that becomes a 1. Okay, I'm going to clean up. -3 times -3 is positive 9. Positive 9 times -3 is negative 27. X to the 4th, y to the 6th. 2 times 2 is 4. X squared times 1. Do I have to put the times 1 in there? Is it necessary? 1 is a multiplicative identity. It's not necessary. Again, this next step is only necessary if you are struggling on when to multiply and when to add. All right, I just regrouped. -27 times 4, x to the 4th times x squared, y to the 6th. You could put a times 1. It's not necessary. Multiply these two numbers together right now. -27 times 4. Let me know when you have that answer.
How did it get to x to the 4th?
I know. I noticed that on my answer key. Thank you. That's a 9th. Yes? It was just me going too fast. Thank you, Elena. If you were writing with me, please fix. And if I confused any of you, I apologize. I was writing too fast. It's not a 4th. It's a 9th. All right. Who did I just call on? Did I call on anyone? Did I say someone's name? I thought I did. No? All right. Amelia, can you tell me what -27 times 4 is? -108. And Amelia, tell me what to do with the exponents. Can anyone help her? What do we do? Add. All 3 or just the x's? Just the x's because they're like bases. So it's x to the 11th and y to the what? 6th. How many of you guys do not need, and it's okay, how many of you guys do not need to rewrite it? You just do multiplying and adding exponents, which is okay. If you're not getting the right answers, try it this way. It may help you visually to see everything chunked up together. Okay. One last, like this type of problem. I'm going to do some other different types and we are done. Okay, number 9. 5j k to the 3rd, 2j to the 5th raised to the 3rd. All right, how is this one a little different from 7 and 8? What do I not have around this first chunk here? Is that okay? Yeah, there's no parentheses, there's no power. Do I have a power on the second one? Yes, so what am I going to have to do with that power? Distribute. Remember, first check. Is there any plus or minus inside these parentheses? Nope. Is it okay to distribute? Yes. Rebecca, what do I put first on the 2 that's not already there? An exponent of 1. 2 to the first and j to the 5th. And then we distribute. And because there's nothing here, this is going to stay the same. 5j k to the 3rd times, and then we're going to end up with what? And I'm going to call on Nathaniel. Can you tell me what it is? 2 to what power? I'm sorry, a little louder. Okay, keep going. J to the 15th. Okay, we clean up. 5j k to the 3rd. What is that? 2 times 2 is 4. 4 times 2 is 8. J to the 15th. Again, if it helps regroup, I'm going to move my work up here. 5 times 8. 5 times 8. What's on this j? I didn't add it in there initially. What's here that I don't see? A 1. Times j to the 1st times j to the 15th times k to the 3rd. All right, so what do we end up with? 5 times 8 is 40. Add your exponents. J to what power? 16. Does k have any exponents to add with? No, so it's just k to the 3rd. Is anybody working faster than me and getting these answers on your own? A few of you? Good, good, good. Okay, number 10, I'm going to squeeze in here because it is a small one. X to the 7th over x squared. This is one of the reviews we did in the very beginning in the review section. As tempting as it is to divide the numbers, we don't divide. What do we do with them? Subtract. So what do we end up with? X to the, and there's no work, that's it, that's your answer, x to the 5th. If you wanted to show work, you could expand your x's at the top and the bottom, cross them out, and that's what you're left with. Got it? Okay. 11, x to the 9th, y to the 3rd, over x squared y to the 5th. All right. I only subtract exponents when I have like bases. I'm going to cover that right there. Are those 2 like bases? Are those 2 like bases? Okay. Now I can only do all this when there's multiple pieces as long as there's no plus or minus. Is there no plus or minus at the top? No plus or minus at the bottom. We're going to subtract exponents. Okay. I'm going to do this one here. What's 9 take away 2? What's 9 take away 2? So x to the 7th power. Does everyone agree? All right, when I look at this one here, I have to be careful because what's 3 take away 5? And what happens with the negatives? They move to the bottom. Rather than working with negatives, here is how I do it. Are there more x's at the top or the bottom? Look at the x's for now. More x's at the top or the bottom? Top. So imagine expanding them out and crossing out. You're going to have whatever's left at the top. Do you agree? How many y's here do I have? 3 and 5. Are there more at the top or more at the bottom? So picture in your head, if you have 3 at the top and 5 at the bottom and you cross out, you will have 2 left over. Where will they be, at the top or the bottom? Why will they be at the bottom? Because there was more at the bottom to begin with. Does that make sense? So instead of doing 3 minus 5, do 5 minus 3 and notice that it's going to come to the bottom. All right, so I will repeat that. You look here, there's more x's at the top, so you do top minus bottom, stays at the top. There's more y's at the bottom, so you do bottom minus top, and it goes to the bottom because there's more there to begin with. That is your final answer. If you'd rather work with negative exponents and then moving at the end, that is fine as well. Okay, big parentheses. 2x y to the 6th over x to the 4th y to the 5th, close parentheses, 3rd power. This is kind of like the ones we were doing earlier, except instead of two terms being multiplied, it's a fraction, but still with the big exponent. Okay, look inside the exponent. Is there any plus or minus signs? I don't mean negative signs. Is there any addition or subtraction signs? So what do you think we're going to be allowed to do with that 3? What is it? Distribute? Did I hear someone say distribute? Now, because it's a big parentheses, I'm not only going to distribute to the top, but I'm also going to be able to distribute to the bottom. That's crazy, but we can do it. Because the parentheses are big and it's around the whole fraction, top and bottom, I'm going to distribute the 3 to the top as well as to the bottom. What do I have to do first? Anybody remember? I've already checked the plus and minuses. What do I have to put in there? The ones. The 2 needs a 1, the x needs a 1. Anything else? Anything else need a 1? All right. Jackson, can you work it out for me? 2 to what power once you distribute? Multiply. 1 times 3 is? 3. Keep going. X to what power?
3.
Good job. Keep going. Y to what power when you multiply? 18. All right. Keep on going to the bottom now. X to the 12th and Y to the 15th. Do you agree it's not that bad? Right? All right. I'm going to work this out. Do you agree these two are the like bases and these two are the like bases? And 2 to the 3rd is just 2 to the 3rd. All right, what is 2 to the 3rd power? 2 times 2 times 2 is 8. All right, let's look at the x's. Are there more x's at the top or the bottom? Bottom. So when I subtract, where are they going to be left? At the top or the bottom? Bottom. So what's 12 take away 3? Louder? So x to the 9th at the bottom because there's more there. Looking at the y's, 18 and 15, they're more at the top or the bottom? Top. So when I subtract, where are they going to be left over at? Top. And 18 take away 15 is what? And if there's nothing left at the bottom, then there's no fraction. You just have everything at the top. All right. Last one. Questions. I know we've gone through a lot. Any questions on any of it or any of this last section here before I move on? Okay. Number 13. I'm going to have A versus B. What if I have 6x to the negative 1 versus parentheses 6x to the negative 1? Do the parentheses make any kind of difference? Do they matter? Are they important? I hear a no. Anyone else? Are they needed? Are they necessary? Any thoughts? Do they make a difference?
The equation if they're there.
They change it, so it's going to change the answer?
Yeah.
Okay, he's saying they are important. It does change it. Yes? All right. I addressed this earlier on the part 1 section. Let's talk about this one. Is that negative 1 being applied to the 6 and the x or just the x? Just the x. I talked about it right here. You guys remember when I talked about it here? Okay, so if it's applied to just the x, where is this 6 going to go? Is it going to go to the bottom or stay at the top? What's the 6 doing? Staying at the top or moving down with the x? Staying at the top because there's no negative. But the x is moving to the bottom and it's x to the positive 1. Do you have to write a positive 1? No, it's okay if you do, it's not necessary. So 6 over x is the final answer. Okay, how is this one different? Is that negative 1 being applied to the 6 and the x? Or just the x? It's the whole thing. Do you agree? So on this one, does the 6 move with the x or does it stay at the top? It moves with the x. And what's left at the top when there's nothing there? Not a 0, but a 1. Now, at this point, do I need to write a power of 1? If it was a squared, what would I have to do with the 2? If it were a 2, what would I have to do? Distribute 6 squared x squared. But since it's a 1, it's just 1 over 6x, and that is the final answer. Questions? Oh.